All right, it looks like our numbers have stabilized, so let's go ahead and get started. Welcome everyone to today's CNCF webinar, Canary Deployments with Kubernetes and Istio. I'm Caitlin Barnard, Marketing Manager for CNCF, and I'd like to thank you all for joining us today. I'd also like to welcome today's presenter, Jason Yee, who's a technical evangelist at Datadog. So just a few housekeeping items before we get started. During the webinar, you're not able to talk as an attendee. So if you have any questions or comments throughout the webinar, there is a chat box and a Q&A box at the bottom of your screen. So please drop any questions that you have in there, and we'll get to as many as we can at the end. And just a reminder that the session is being recorded and will be sent out afterwards along with the slides within about 24 hours. And with that, I'll hand it over to Jason to kick off today's presentation.
Thanks, Caitlin. Welcome, everyone. So hopefully you're here to hear about deployments. So deployments, right? What could possibly go wrong? That's a stupid question because the answer is obviously a lot. That's why you're all on this call. Anybody who's ever made a deployment has inevitably encountered a problem. Whenever I talk and I'm in front of an audience, I usually ask people that, who's experienced a deploy issue today or this week or this month. And inevitably, by the time you get to the point of this month, everybody's raised their hands for that, because it's really obvious that deployment, as much as we try to make them go flawlessly, there's always problems. And so I like to bring up this meme that it's the most interesting man in the world. It was a Dos Equis campaign, but adapted for tech, the meme is, when I do blank, I do it in production. Because oftentimes we do silly things and we just do them straight in production without even trying things in staging or things like that. It's kind of this bravado. But the problem when it comes to deployments is that when you deploy to production, you always do that in production. So as close as we try to get test environments and staging environments and developer environments all looking exactly the same, you still end up deploying bad things to production. And some of that really isn't even the code that you're deploying being bad. It could pass all the tests, and it could simply be that developers thought that users would use the application or the product in a certain way, and you deploy and everything passes the tests and deploys cleanly, only to find out that there's a fundamental flaw with how we think our users are actually going to be using our applications. So that's why it's basically impossible to guarantee against deploying bad code or code that doesn't work the way we think it should. And I think that's why Canary deployments and using a Canary deployment strategy should be critical and should be the strategy that we adopt for every single deployment that we do moving forward. And I'll be showing you with Kubernetes and Istio how that can be a much easier process. So a little bit about me before I dive into this. I am Jason, a technical evangelist at Datadog. I like to say that my job is essentially docs and talks. So I help out with our technical documentation. I do quite a bit of code side, maintaining some integrations and things like that. And I also travel around to events and do webinars and essentially do a lot of the community outreach for Datadog. So both as someone who gets to go out there and espouse cool technologies and promote monitoring in general, but also as someone who can take your needs and relay those back to our product teams within Datadog. Aside from that, I am a nomad, so I travel around. Bonjour de Montreal, currently in Montreal, but I've been traveling around. It's been about one city every week. So I'll be in Portland, Oregon next week. If you're in Portland, hit me up. I'd love to say hi. But I'll be traveling around for the rest of the year into December, and then I plan on settling down in Portland, Oregon. Also do love whiskey, so that's a photo of my favorite whiskey that's available. And also am totally obsessed with Pokemon Go. So if you play, that's my friend code. Feel free to friend me. I will send you gifts from around the world. A little bit about Datadog. Datadog is a SaaS-based monitoring platform. So we do monitoring, what you traditionally think of as monitoring with metrics, automated alerts. But we also do APM, so we'll do distributed tracing. We also do log analytics, which is our latest product. To give you an idea of the scale, on the metrics side, we handle trillions of metrics points of data every single day. If you count traces and logging, then that number is just astronomically huge. We are hiring, so if you are considering a new opportunity, if you'd like to help build amazing tools that help other engineers be better at their jobs, we are hiring, so take a look at that link. And just to give you a caveat as we talk about this, we do Canary deploys within Datadog. We are running Kubernetes. Almost all of our services are running on Kubernetes now. And we have been playing a lot with Istio and working on that. So what we call our compute team, which is our infrastructure team, they've been doing a lot and contributing back to the Istio project around the multi-cluster abilities. So all of this said, before we launch into this talk, Kelsey Hightower back in February gave this warning that Istio's very early project. Don't run out and try to deploy it in production because you'll end up on the news in a bad way. And this was when Istio was still version 0.8. So I'd like to update this. I haven't talked with Kelsey about Istio recently, but Istio is now 1.0. In fact, it's 1.0.2, and 1.0.3 is going to be coming out soon. The APIs are mostly stable. You'll notice in the YAML files, there's a couple spots where it still says alpha, which means that theoretically they could change. But at this point, Istio is stable enough that you should be really considering whether you need a service mesh. And if you do, which I think most people who are running Kubernetes in large-scale environments with a lot of microservices, I think those people do need service meshes. So if that's you, it's something that you should consider going out and trying and playing with, because I think it'll solve a lot of the problems that you either currently have or will have as you grow out a large microservices distributed architecture. So let's talk about how we're doing deploys currently. Blue-green deploys, very, very common practice these days on how to deploy software. If you're not familiar with blue-green, it really doesn't matter what color it is. I've heard people call these red-black. I've heard it all sorts of colors across the entire color spectrum. But the concept is very simple. You start with version 1 of your application, and you have version 2 sitting in the sidelines. It's deployed on infrastructure, but it's hidden behind some sort of load balancer. And when you want to deploy that new software, you simply make a change to that load balancer. And that load balancer could be something as simple as a DNS entry, or it could be even on the software level. If we think about how Capistrano deploys worked, Capistrano really was just using symlinks here. So you would symlink, for example, your www folder for web application from one folder to another, and now your new application would be deployed. And this was great at the time because it offered this pro of having basically zero downtime deploys, right? In the time that it took to just make that switch from a load balancer or DNS or symlink, really you had no downtime. And it always promised easy rollbacks, right? If I needed to roll back from version 2 back to version 1, well, I could just go into my load balancer settings or one of my other settings and make that flip back. And now all traffic's getting directed to that old version of my software. I like to say that the idea of this was it's a giant undo button, right? You can make that simple change. But the cons of it were always this easy rollbacks. And I say that in air quotes because as anybody who's ever deployed a lot with Blue-green knows, you know that it's one of those things that when you make that change and you move back, yes, your code is now looking at the old version of code, but our applications are never truly stateless, right? We have data that's stored along with them. So you always have this issue that, one of your updates may have made an update to a data store, like a database schema. And now when you do this rollback, suddenly those queries that used to work with the old state of your data no longer works with the current state of your data because it's been updated, and your data stores are much harder to roll back. and so things inevitably break. If you're using Kubernetes, well, the nice thing is Kubernetes uses a process called rolling deployments. So rolling deployments are quite a bit better than Bluegreen. So if we're looking at rolling deployments, how does that look? Well, it's similar in a sense to Bluegreen. You have a bunch of now replicas of one version of your software, but similarly, you have a load balancer sitting there, and this would be Kubernetes itself if you're running that. And you simply remove one of your old versions and spin up one of your new versions, and you keep doing this until all of your replicas are rolled over. And one of the nice things now is that, again, this provides us with almost no downtime, but similarly, because we're having to support version 1 and version 2 of the software at the same time, it means it forces our developers or our DBAs to keep that data store accessible and compatible with both versions of our software. So that makes things a lot easier if we do need to roll back. So then what is a Canary deployment? Well, a Canary deployment is really the idea that if I have a problem, if I do something really stupid, do I want that to be in front of a very large audience, or would I rather constrain that and have it to a very small audience? Similarly, if I were on this webinar and I say something really ridiculous and stupid, or I say something wrong, well, I'd rather say that if there's only one of you on this call. But obviously, there's a lot of people that have joined us today, so if I make a mistake, the ramifications are much larger. So Canary deploys really do look similar to rolling deploys. You have a bunch of replicas of one version of your software. You have your load balancer essentially redirect some of your users to a new version as you tear down your old version and you spin up that new version. But rather than continuing this, you pause and you monitor. So this is one of the areas that Kubernetes, unfortunately, is really good at rolling deploys because it's very fast. It doesn't really give you the opportunity to pause and to monitor. But with Canary deployment, then we would continue on. If everything looks okay, if our monitoring systems say, hey, this looks exactly the way we want it to, you continue, and then you pause again and you double check, and you keep going, pausing occasionally to see and to check your metrics, right? So think of it as a slow rolled deploy. And when you're done, then it's obviously time to party. So Canary deploys are fantastic because they limit the scope of what we're doing. In case we have problems, we're limiting our blast radius. There's far fewer ramifications when we only expose a small group of users to a potential problem. They also provide us those easier rollbacks, similar to what we saw with rolling deployment, but by having this graduated or this stepped approach, it allows us to roll back whenever we see problems, or to even not even roll back, but just to pause, to actually look into things when we see something that might be erroneous. Another thing that a lot of people don't take advantage of when they're doing Canary deploys, but I think is a fantastic feature, is that it's much more load tolerant. When we talk about things like Kubernetes or going to the cloud, whether that's managed Kubernetes, something like EKS in Amazon, or GKS in Google, or any of the other managed providers, or whether that's just running your own Kubernetes on top of cloud infrastructure. One of the nice things is, as we roll things out, if we see that it's having increased demand on our resources, it gives us a chance to actually scale those up, right? So if suddenly I see that whatever my new deployment is, maybe it's a fantastic deploy and I'm seeing thousands more users hit my application because it's a much better version of my application, well, now I can scale up those resources. And another thing that Canary deployments provide is concurrency. So as you're able to roll out multiple versions of your application, you can start to concurrently roll those out. You can do things like A/B testing, figuring out which new feature, when you roll it out, which one actually has better performance or engages your users more. So that's the whys of Canary deploys. Let's talk about how we should think about the strategies of how we actually can implement this. So some of the strategies, when you think about Canary deployments, you really should focus on your end users, right? Your end users are the reason that you have your job, that you're doing what you do, whether those are external to your organization or internal. But you should think about how you choose the sample sets, those subsets where you deploy that Canary deployment. And so number one way that most people choose to do things is random, right? You just say, I'm going to randomly send 5% of my users to my new deployment. Random, unfortunately, as we all know, anybody who's ever worked with technology, we know that computers are very, very bad at random numbers, right? There's always some sort of issue, whether that's people forgetting to seed random or other things, but random usually doesn't give us the results that we want. So I highly recommend you think about representative sets. So representative sets essentially means, again, keep your focus on your end users. How are your end users going to be using your application? Think about their geography. Where in the world are they, right? For example, I'm currently in Montreal, which is North America or Eastern North America time. But if I'm going to roll out a new feature and it particularly targets or it particularly highlights uses that, for example, my customer base in Australia might be using, well, I have to think about where they're at and what time is it in the world, right? So if I deploy this and I have a Canary deployment and I look at it and say, hey, it looks like everything's fine, resource usage is perfectly normal, but it turns out, well, those people are all asleep, then it's not a useful Canary deployment. Also consider the usage patterns for your users. When you roll out a new feature, who are the users that it's intending to target? Is it logged in users? Is it administrative users versus end users? So think about these usage patterns and what you're rolling out. And this really does force you to think in terms of DevOps. And when I say DevOps, I don't mean automation or things like that. I mean the actual developers talking with operations to work on a Canary strategy. When your developers are working on that new feature, you have to really engage with them and figure out what they're working on, who those users are, come up with those use case stories, work with operations to deploy those and to implement your Canary strategy. You also have to think about the granularity. And when I say granularity, I mean those steps. So in my example earlier, I had 4 replicas and I said I was having it pause in between each of those as replica from version 1 rolled over to version 2. But we have to think about the granularity. How are we going to target a small set of users that's enough users for us to monitor? And then how are we going to scale that up to the next step and the step beyond that? Because you really don't want your Canary strategy to be, let's deploy to a small subset, and if it works okay, we're just going to go whole hog, 100% of our users get this. You really want to increment that up, at least with a few steps. Grubhub is a customer of Datadog, and they recently had a talk about how they do Canary deployments at one of our user summits. And they have this interesting strategy that I hadn't even considered, where they do a Canary deployment to small cities and small towns. So for example, in the US, if you're US based, they might roll out to a city like Detroit before rolling out to a larger city like Chicago or New York, before rolling out countrywide. So start to think about that. How can you segment off your users in ways that will scale up and provide you with useful feedback? And as mentioned, Canary deploys do give us that opportunity to scale up our infrastructure as well. So along with that, think about the resource mapping. As you roll out a new feature, how is that new feature going to impact your infrastructure? Are there additional calls to a data store or an API endpoint? Will that cause additional load or network traffic to that particular resource, that data store or that server that's providing that API? So start to think about everything that's involved from a user perspective and from an infrastructure perspective. All of this does assume that you are monitoring, though. You can't do a proper Canary deploy if you're not monitoring how you're using your resources, how people are using your application. So some things to think about when you're actually doing a strategy around Canary deployments for your monitoring. First is that you need tags, whether those are tags in Datadog, whether those are labels in Prometheus. You can't think of a data point as simply a value of how much it is and what it is and when it happened. You really need that tag of where did this come from? What application was it? What version was it? what release, things like that. Because without additional metadata, it's going to be virtually impossible for you to figure out what metrics are coming from your Canary deployment versus what metrics are coming from your actual production environment. Along with that, you have to start looking at the extremes. Many people already look at the P90 or the 90th percentile when it comes to things like latency or other metrics. Some people push that further to the 95th. But when you start to roll out to canaries, you really need to start thinking about pushing that all the way to the 99th. Start to go all the way to that boundary, because if you're rolling out a canary deployment to a small subset of your users, any sort of errors or latency issues or problems that they have, when that's just a small group, those will scale massively as you roll out to all of your users, right? So that small problem will become a very, very large problem. So you need to look at those extremes and start to anticipate when you see a problem out at the extremes that may grow. The other thing that you need to look at is outliers. And I like to call outliers that one of these things does not look like the other, right? Outliers really is the idea that with a canary deployment, hopefully you'll have some sort of graph or some sort of dashboard that shows you that you can highlight, where's my production metrics, what do these look like, and then have some sort of machine learning or way to tell the difference between what's an outlier, what isn't part of that normal grouping. The other thing that you need to think about is anomalies. And I like to say that anomalies is, this isn't like what it was before. It's not acting how it has before. And this is a key point, that this is where machine learning, or if you've got AI or you've got some sort of algorithmic anomaly detection, this is where it comes in really handy. Because if I show you a graph like this and say, well, how is this canary deployment different, right, from how things have worked in the past? Well, with machine learning, you can start to derive more information. Machines can spot patterns better than we can. And obviously, nobody wants to stare at this dashboard all day, but it can highlight things like this, like, well, what happened on this particular Tuesday? Why didn't we have the normal bump? Was it a holiday? Or maybe it is something that's anomalous that we should look at. So using machine learning, using some AI, really will help you to understand the context behind your canary deploys. Some other signals to watch when you're going into your monitoring. I particularly like the 4 golden signals, which was part of the Google SRE book that was published by O'Reilly a couple years back. And so the 4 golden signals, I've reordered them. I like to call it LETS, L-E-T-S, because it helps me remember things better. But the L is latency. So when you're looking at your canary deployments, take a look at changes in latency, right? Again, push all the way out to the P99. How's your latency changing? Because that'll be important for your users. The E in LETS is for errors. So what are the errors that you're seeing? Not just error rates, but what are the actual errors? Because as you deploy new code, you're gonna see different errors than you have in the past. The T in LETS is for traffic. So traffic is sort of a double-edged sword. You might see increased traffic, and that could be a fantastic thing. Could mean that you've deployed fantastic new features and your users just love it. And so you're seeing much more traffic. But it could also be a bad thing. It could mean that maybe a developer released some unoptimized code that's making duplicate requests against a data source or an API. Similarly, decreased traffic could be a good thing. It could be that your developers optimized code and now they're only making 1 call to that data store rather than 2. Or it could mean that you deployed something bad and users are having problems actually using the software. So take a look at those changes either way. And the last is saturation. So take a look at how your infrastructure, how your resources are being used compared to your deployment. Again, if you see an increase in resource usage, that could be a good thing. And the Canary deployment could allow you to scale up. So take a look, again, both ways. So what's all of this have to do with Kubernetes, right? Well, Kubernetes, how many people listening think that this is Kubernetes a container orchestrator, right? You deploy containers on it and manages your containers. Well, I used to think it was a container orchestrator, but it's actually not. It's a service orchestrator. The base unit within Kubernetes is a service. The containers, the pods, the rest of it, they're all ephemeral. The thing that matters, again, to hammer home the point, is you have to be aware of your users, and your users care about services. They don't care about your containers or your pods. So those are just the resources that provide the service. So services are what we care about. And if we're thinking about deployments, well, if we wanted to deploy one service with Kubernetes, it wouldn't make sense to have two separate meshes of services and just have one giant load balance in front of all of them. So obviously Kubernetes makes that much easier. As a service orchestrator, something that manages services, it handles those service deployments, right? So we can change individual services within Kubernetes. It'll do rolling deployment. It's really fantastic at that. So why might you need a service mesh like Istio? Well, as mentioned, Kubernetes does those rolling deployments very, very well, right? It does them so well that it happens quickly, but it doesn't do Canary deployments very well at all. So how would you do it, right? Give you an example. Kubernetes, let's set up a service, right? So I have a basic web service here. I'm gonna have my YAML. It says I'm declaring a service, give it some metadata, which is my application. I'm gonna expose port 80 because it's a web application. So that's the service part, but if I wanted to actually implement this, well, I need a deployment. And my deployment sets up my pods and how many replicas I want. So if I were to do a deployment with version 1 and version 2 of my application, well, if I set them to the same replicas, what would this do? Well, generally, this would just split my traffic 50-50, right? I have one service, I have two deployments. So when it comes to actually directing traffic or doing any sort of routing, Kubernetes just sort of is agnostic. It says, I don't know which one of these really matters, so it's going to split my traffic 50-50, mostly randomly. So if I wanted to do a Canary deployment, well, you could see how this could be useful. I could deploy version 1 of my application with, for example, 9 replicas, and version 2 with 1 replica, and now I'm generally going to get 10% of my traffic going to version 2. So I can start to scale this up as a Canary deployment, right? Everything looks good with 9 and 1. I can now shift that to 8 and 2, or I can shift that to 7 and 3, all the way to the point where I can go from one version of version 1 or one replica of version 1 to 9 replicas of version 2, and then I just delete version 1 and shift version 2 to 10 replicas, right? Because there is a bug in Kubernetes, you do not want the replicas to be 0. But you can see how this could be a problem, right? If I wanted to, say, do 1% Canary deployment to version 2, well, do I really have to do 99 replicas of version 1 and 1 of version 2? Like, that's kind of silly, especially if I don't need 99 replicas. On top of the fact that I gave you all that great advice about how you should think about Canary deployments and have representative sets and all of this other information, we're really just locked down to having percentages with Kubernetes. So this is why Kubernetes, while it's a fantastic tool, not so great at Canary deployments. So what's a service mesh get you? Well, off the bat, it gets you routing and load balancing, right? So this is, again, going to be the important parts when it comes to Canary deployments. It's how we do that routing and the load balancing. But it also provides you some better service discovery. Other things that it provides is timeouts and retries. So Istio in particular will allow you to set a timeout for your services and an overall timeout. And it'll do retries for you. So your developers no longer have to worry about what if that other service that they're making an API call to, what if that's down? How do they manage that in code? You can just automatically have your service mesh like Istio handle that. It also handles policy enforcement. So rather than relying on your developers to always implement a secure connection to TLS encrypt all of their calls, you can enforce that within a service mesh. And the final thing that it provides is a really great point for monitoring and tracing. Because all the network traffic is flowing through your service mesh, It's a great way to start getting some of that tracing down. You can monitor how long things take, and you can start to trace requests as they make calls to services, and you can put timers on those to understand which services or which parts of your application are taking the most time. So how's this all work? Well, you have Kubernetes, it's monitoring a bunch of your services. In particular, it's going to be having a bunch of pods. So the first thing that you have to do is add a data plane. And the data plane really is just going to be Envoy. Envoy is a fantastic CNCF project, started by the folks at Lyft, and it's obviously open source. But really, when it comes to implementing Istio, it's relying on Envoy for what we call that data plane. And in order to do that, really, it's going to modify your deployments. It's going to add a init container that's going to modify your IP tables and redirect all of your container traffic through an Envoy sidecar. So now that's the first step in starting off. We have all of our network traffic going through Envoy. The next portion of it, and the reason that I think Istio is so fantastic, is it provides us this control plane. The control plane is really what I like to say is the guts of Istio. It's where we have the ability to create new modules, to update our logic if we want to have custom logic, to pull out monitoring and metrics, to do a lot of the things that makes Istio so exciting. Those are all within the control plane. So I won't dive too deep into the guts of Istio, but let's talk about how we should do, or how we would do, a Canary deployment with Istio. What does that actually look like? Well, we start off again with a service, right? This is, again, Kubernetes YAML. We have a service. It's basically the same. Istio doesn't touch your services at all. When it comes to our deployments, again, it's just going to be a basic YAML file. And for the most part, it's going to be the same as well, at least as far as we're concerned. As far as operators, you don't have to do anything special to your deployments. And the reason for that is Istio comes with a fantastic tool called kubeinject. So really what this does is you pass your YAML in. It does an injection. Like I said before, that injection really is the guts of it, is to inject an init container so that before your service or before your pod starts up, it's going to modify those IP tables. Now, this isn't the standard way of starting Istio, but it's the way that I recommend for most people, because just like when someone tells you to, oh, just curl this shell script and pipe it to bash, you know, that's a really a silly thing to do because you have no idea what's in that shell script. Similarly, even though Istio is an open source project and it's totally safe, you should know what's going on. So I highly recommend that in between this first line of Istio-ctl kubeinject and the kubectl apply, really, you should run a diff of your version of that YAML and the Istio version. You should take a look at what changes are being made. It'll really help you understand what's going on with Istio. Once you understand that difference, then of course, go ahead and apply that, and you'll get that rollout with Istio. The other way, though, the more standard way of implementing Istio is through Kubernetes mutating webhook admission controllers. Really, it's just a fancy way of saying there's a webhook within Kubernetes that allows for auto sidecar injection. So you'll just namespace your service with the Istio namespace to allow it to identify what you want to auto inject. And then because of the webhook, whenever you do a deployment, whenever you apply some YAML that'll do a deployment, it'll automatically note that, and that webhook will be invoked, and the init container will be started. So just like Kubernetes is a service orchestrator, it's service-oriented, Istio is a service mesh, and so it is also service-oriented. So the first thing that we would do to do a Canary deployment is that we set up a virtual service. This is essentially similar to setting up a service in Kubernetes. It tells Istio that we have a service that's going to be running. This one's really basic. It's just pointing out that I do have a service. I've got a basic route there. The second step is to set up a destination role. And this is what I like to call the glue. This is the glue between Istio and Kubernetes. So really all it's doing here is going to be tying my virtual service in Istio to a deployment in Kubernetes. So here's just some really bare bones YAML highlighting the important parts, but this is how it connects. So it's really just going to connect the name of a subset and a version to that template metadata for my Kubernetes deployment. Really pretty simple. But you can see, because this is so simple with that destination role, if I wanted to do a Canary deployment, well, then I would simply do a secondary deployment like I had before with Kubernetes. But rather than telling Kubernetes or letting Kubernetes randomly split that, I'm going to put that entry into that destination role. So again, I'm going to apply that glue and make that second deployment available to Istio. And then from there, really everything, again, is service-oriented, so I get to control everything through my service. So here I can set up some additional routing, right? So in this case, I've said that the weight is 80% going to go to my version 1 of my application, and 20% is going to go to version 2. But as mentioned, there were all these great advice about you should use representative sets and you should think about various things. And that's the fantastic thing that Istio provides us. It really gives us that ability to add additional layers. So rather than just setting a static weight of a percentage, we can actually do things like inspect headers and look at cookies, things like that. So we can target logged in users, or we can use a GLYP lookup service to target users from a particular part of the world. So what else can Istio do? Obviously, it can do tons of other things. That was just the simple Canary deployment, or the simple routing rule for Istio. But as mentioned, service meshes like Istio provide you a lot. Timeouts and retries, TLS policy enforcement, metrics and monitoring, things like that. So take a look at the documentation and play with Istio. So just a quick recap. Service meshes give you a lot more control than what you'll get out of the box with Kubernetes and what you'll get from Kubernetes itself. Kubernetes is a fantastic project, and it's nicely limited to the core things that it does really well. But service meshes like Istio will give you the control that you need. When it comes to Canary deployments, think about representative sets. Think about your end users. How are they actually using your product? And then think about how you can granularly scale them up. When it comes to monitoring, you absolutely need monitoring if you're doing Canary deployments. If you're not monitoring, your Canary deployments are going to be completely useless. So ensure that you're using tags, or you're using labels if you're using Prometheus. Think about outliers, the things that don't look like the others, and the anomalies. Take a look at your past history of your metrics. And then when it comes to what to watch for, look for changes in latency. Look for errors, not only error rates, but what types of errors. Take a look at your traffic, whether that's gone up or down. Both of those could be either really good or they could be bad. And similarly, take a look at your saturation. How are your resources doing? And if they're doing fine, but they're creeping up, gives you a chance to scale up. And then finally, my number one takeaway point, go play with Istio. Istio is a fantastic open source project. It's making a lot of headway. It's super exciting. I think you'll really love it, so go play with it. And with that, we'll open it up to questions.
Awesome. Thanks, Jason, for the great presentation. So we have some time for questions now. And just a reminder, if you do have a question that you'd like to ask, please drop that in the Q&A tab at the bottom of your screen, and we'll get to as many as we have time for. All right. So one of the questions is, if an application is working in staging, but it fails once it's deployed to production, can you kind of talk about how you would approach this in a Canary deployment?
Yeah, so if you deploy something, it's working great in staging, you make it the same deployment to production, and things aren't working. It really depends on why they're not working, right? And so again, it really comes down to the monitoring that you have. When you deploy that, your monitoring tools, whatever that is, should note that it's not working, and there should be other additional information about that. And so the way that I like to approach going from monitoring, seeing that something's wrong, to actually figuring out the issue is really just this drill down. It's sort of this circular loop, imagine a for loop. But it starts with what we call a work resource, right? A work resource is really, or work metric is really just a top level metric. So it could be things like my users aren't able to see a page. So then you have to drill down into what are the resources that provide that, right? It's probably going to be a web application. That web application is composed of a data store and a web server and maybe some application like a Python script or a Ruby script, things like that. So you drill in and then check out the events that have changed, right? Like, has anything changed about this that we weren't expecting? And then continue to drill down, right? So those resources, things like the data store, become your work metric, right? So what does a data store need to run? Well, it needs disk space and it needs processor, right? So you start to drill down. So I highly recommend that you go from a top-down approach, right? What are my users seeing? What are my users experiencing? Figure out the things that support that, and then look at each of those and continue to drill down is usually the best way to do that.
And then kind of going off of that, how can you automatically roll back to a previously known good version if an issue is found with the Canary deployment?
Yeah, so the nice thing is because everything is API based, really, with both Kubernetes and Istio, we generally think of interacting with them as YAML because YAML files are easy for humans to read and to edit. But at the end of the day, it's really an API that's driving it. So if you wanted to automate Canary deployments, you could use a tool like within Datadog, we have a webhooks integration. So you could use something simple like webhooks. When I do a Canary deployment, wait for a certain amount of time, monitor my certain metrics. If they all look good, then you can automate going forward, or you can automate going backward by invoking a webhook. So it's different with all monitoring products, but generally within Datadog, the way that you do it is you set up an automated alert. It's the same type of alert that would fire off PagerDuty or VictorOps to alert you to a problem, but rather than sending you a message or sending a message through PagerDuty, all it's going to do is fire off a webhook. So that's one way that you can automate it.
Awesome. And another question is, how would Canary deployments and dynamic database management work with tools such as Liquidbase?
That's a great question, and I'm not too familiar with Liquidbase. So yeah, since I'm not familiar with the tool, I'm assuming what you mean is, well, I can make assumptions about what you mean by dynamic database, but again, I'm not too familiar with what's being referred to there. So I think I should probably pass on that, but whoever asked that question, happy to dig into that further. So my email and my Twitter handle are up on screen. Feel free to ping me on one of those methods, and I'd be happy to dig into that more with you.
Awesome. So do you need to define a service in Kubernetes before you create a virtual service in Istio, or does the virtual service take the place of the Kubernetes service?
That's a good question. I've always defined a service before implementing it in Istio. To be honest, I'm not quite sure what happens if you don't implement the service in Kubernetes. Yeah. That's something to try out. That's a fantastic question, and it's just one of those that I think I'm just so used to with Kubernetes, just always doing a service in a deployment, that I've never bothered to do that. Again, hit me up on my email, and I would love to just explore that and see what happens. My suspicion is that it's going to be missing something, and things might break. But I might go and play with that after this call is done.
Awesome, lots of good questions to dive into further. How does this fit into a CD pipeline?
Yeah. So within a CD pipeline, you could automate it again because everything's API driven. So you could automatically run a Canary deployment. But generally, I'm very much a fan of continuous integration, but not continuous deployment. So when it comes to actually, committing your code and pushing that, I don't think that by default everything should like push out into production, even though it is being. So I would say that if the idea is to do a continuous deployment, maybe not, at least to production. So generally, because if you're doing a continuous deployment to a staging environment, I'd say just go ahead, go whole hog with that. Like, there's generally no reason to canary to a staging environment. So that's where I would see the CI part going. When it comes to production, I'd say that it should prepare things. You might want to have it automatically generate YAML for you. But when it comes to actually deployment and running the Canary deploys, I'm very much a fan of manually doing it, simply because I've seen automation run away way too many times. So that might be my own PTSD getting invoked there, but I highly recommend that you just do things manually when it comes to deployments and monitoring what's going on.
All right, can you talk a little bit about the process to add Istio to an existing Kubernetes environment?
Yeah, the process is really pretty simple. The preferred way these days is to use a Helm chart. So if you go to istio.io and you click on, there's a button that'll have you download things. And that download really is a bunch of YAML files and Helm charts and the Istio CTL command itself, the binary, which is the thing that just modifies your YAML files. But when it comes to actually deploying it, it really is, Istio is just a bunch of namespaced services and pods that are running. So there's nothing magic about it. It actually is just an application that's sitting on Kubernetes, similarly to any other application that you would deploy. But yeah, the default way or the preferred way these days of deploying it is just to apply the Helm chart.
All right, so this next one is about kind of Envoy versus Istio. So Envoy supports traffic mirroring and shadowing. Do you think that Istio will expose and support this? And does that reduce the need for Canary deployments?
Ooh, that's a fantastic question. I don't know if Istio will support that. I suspect that they will. Like any open source project, it really comes down to what I like to say is a duocracy versus democracy. Democracy being that when enough people start saying things, that things generally get done, or the will of the people. Open source is very much a duocracy of, if you propose it and you'd like to see it and you submit code to the project, that's how things get done, right? You have to actually start to get involved. So that's one way to get that going, is just to like start taking a look at the code, figuring out how you can add that, start working with the community to add that if it's something you really want to see. That said, shadow traffic is fantastic. For those who don't know who are on the call, shadow traffic essentially is when a request comes in, rather than just routing that request, for example, to a Canary deployment, actually just like splitting that and saying, I'm going to send this request to my actual production version, that's going to run in one way. And then I'm also going to send the request to a duplicate version of my infrastructure or my application that's testing out a new thing. So essentially allows you to Canary deploy without ever exposing that Canary to your actual end users. And I think that's a fantastic way to do things. I think that if it were implemented, then yes, essentially, if by routing things to that shadow version, it may negate some of the need for Canary deployments. And I say may because with shadow traffic, now you are having to set up duplicate environments. And depending on the size of your environment and the size of your organization, what you're running, that may be cost prohibitive, right? If I suddenly have 100 developers all working on different features, multiplying my current infrastructure times 100, even if just parts of that infrastructure could get very expensive. So really depends on the organization, your application, your needs, but I think shadow traffic is going to be a very, very widely used tool in the future.
All right, so does Istio replace a service mesh like Linkerd, or can it potentially supplement Linkerd?
That is also a fantastic question, partly because Linkerd is a CNCF project, and surprisingly Istio isn't, or at least not yet. There's been talk, but nothing has been decided upon, and it hasn't been applied for yet. So that said, it really depends on who you talk to. You know, if you talk to the folks at Buoyant who have created Linkerd, they would tell you that Linkerd and Istio actually work really, really well together. So Linkerd, as I understand it, does a lot of the data plane layer. So essentially you can replace Envoy with Linkerd, and then use Istio to provide additional control plane elements that Linkerd doesn't. So it really depends on how you're using Linkerd right now and what sort of additional features you would like to see. Potentially then they could work well together, but depending, again, if you're using Linkerd for some of the basics, and those are also basics provided by Istio, then it may not be a good reason to run both of them. They may be duplicating efforts.
Awesome. Can you talk a little bit about how Istio works in an environment with multiple Kubernetes clusters?
Yeah, so that's a fantastic question. That's actually something that Datadog's been working on quite a bit. I haven't been on, so I'm not on the team that's actually implementing that, so I don't have too many of the details. For the person who did ask that, feel free to send me an email. I'm happy to connect you with some of the engineers on that team, and they can dive into it a little bit more. But as I understand it, you know, Istio really, with multi-clusters, the trick just becomes where you want that control plane to be managed. So that's something that you know, they're working on with that project. There is some documentation around that, but again, I'm gonna say, hit me up. I'm happy to connect you with the engineers on our team who are actually doing that in production.
All right, another one. How would you configure a load balancer to work with Istio?
Yeah, so generally, you know, Istio is going to be handling all of the load balancing and routing for you. So if the idea is, you know, if you're in public cloud and you've got, you know, a load balancer provided by your public cloud, then really you just want to point your traffic directly to Istio. Istio has its own ingress and egress components that'll handle all of that for you. So it's one of those things that if you have a load balancer out front, really to simplify things, I would say push everything into Istio rather than trying to manage it in both places.
All right, so do you know if Istio Glue can be managed by Spinnaker? And if not, do you happen to know if it's being worked on?
I do not. I don't know if it, I'm assuming that Spinnaker actually has integrations, but that's not something that I've looked into.
All right, I think we're at the end of our questions for today. If for any reason we missed something or you have additional questions after the fact, please feel free to send an email to either webinars@cncf.io or contact Jason directly with the information on his slide. So with that, thank you everyone for joining us today. As a reminder, the webinar recording and slides will be online within about 24 hours. And we look forward to seeing you at a future CNCF webinar. Thanks again, Jason, and everyone have a great day.